Good morning. In the last lecture, we have started with the variable acceleration motion. Before that, I explained you what it means by displacement. So, displacement is the position of a particle with respect to some origin. It is the shortest distance of a particle from origin in a particular direction. Being as a vector quantity, you can express it in the vector form, or you can use the sign convention to express the displacement. I told you that if the position is on right side of the origin, you can consider it as a positive. If the position on left hand side of the origin, you can consider it as a negative. If in vertical motion with respect to the origin, if the position is above origin, then the displacement vector is upward, which can be considered as a positive. So if the position is below origin, can be considered as negative. So you can use this sign convention for the displacement. Then I told you about the velocity. Velocity is the rate of change of displacement with respect to the time. Okay, we have written that the first average velocity is the change in displacement upon change in time. And when this change in time is very, very small, here, then this average velocity becomes the instantaneous velocity. Okay, which can be written as ds by dt. Then I explain you about the average acceleration. This average acceleration equal to the change in velocity upon change in time. And when this change in time is very, very small and approaches to zero, here then instantaneous acceleration, or simply we can say that it is acceleration which is the rate of change of velocity with respect to the time. I told you that the velocity vector is always tangential to the path and consistent with the direction of motion, whereas the acceleration vector is directed towards the unbalanced force. The acceleration vector is always in the direction of unbalanced force. Okay, and magnitude is the rate of change of velocity with respect to the time. Okay. Then, in motion of a particle, here there are two types of motion. One is the rectilinear and other one is the curvilinear. Rectilinear translational and curvilinear translational motion. Particle doesn't have the rotational motion. So in this lesson, we have to study only rectilinear and curvilinear motion of a particle. Out of that, we have started with the rectilinear motion. And in rectilinear motion, here the first side, we have started with the variable acceleration motion. Here before that variable acceleration motion, there is a topic of uniform acceleration motion. When the particle moves with a uniform acceleration motion, UAM, here then we can use the kinematic equation as V equal to U plus AT, first kinematic equation. Second kinematic equation, we can use S equal to UT plus half AT square. And third kinematic equation, we can use V square equal to U square plus 2AN. This kinematic equation we can use for the uniform acceleration motion, and this topic is for the self-study. So you study it yourself. Here in our question bank, the questions on this uniform acceleration motion as well as theory on this uniform acceleration motion is given. You first read the theory and try to solve few questions on this uniform acceleration motion. Okay, because that topic is given for the self-study. Okay, in exams the question may ask on the uniform acceleration motion also. Okay, if you have any doubt, you can ask me the doubt. Then, in this uniform acceleration motion, yes? Any difficulty? कुछ difficulty है क्या?
No, sir.
No. Okay. In uniform acceleration motion, when I write S equal to UT plus half AT square, here I am assuming that the particle starts its motion from origin. It means that at t equal to 0, the displacement of a particle is 0. And that's why the formula becomes S equal to UT plus half AT square. If there is some initial displacement, here let S0 is the initial displacement at t equal to 0, then the same formula can be written as S equal to S0 plus UT plus half AT square, where S0 is the initial displacement. Here the initial displacement is 0, means the particle starts its motion from the origin. Okay, so this formula we can use for the uniform acceleration motion. Then I told you about the variable acceleration motion. The second type of motion is a variable acceleration motion. In between that, there is a uniform velocity motion also. In uniform velocity motion, there is only one equation, s equal to vt. Okay, and velocities remain constant. Initial velocity equal to the final velocity. Then in variable acceleration motion. Now, name itself indicates that during the motion, the acceleration varies, and it varies with respect to some other parameters. Yeah, we have considered the three cases. One, the acceleration is a function of time. The second, acceleration is a function of displacement. And third one is the acceleration is a function of velocity. Here, so this is one equation of motion which is given, and from this one we have written some another equation of motion. We have written the velocity as a function of time by integrating this equation here, and by integrating this equation of velocity, we got the equation of displacement, which is displacement as a function of time. So when we write acceleration is a function of time, velocity as a function of time, and displacement as a function of time, here, so it is known as kinematic equation of motion. These are the kinematic equation of motion, which are the equation of motion, which gives you the relation between the different parameter of the motion. Okay, clear? Similarly, you know, in the last lecture I explained you how to write down the equation of motion when the acceleration is a function of displacement and acceleration is a function of velocity. I hope you all are comfortable with that. Here, same procedure is there. You have to replace this a by dv by dt or s v into dv by ds. Then separate the variables, integrate, solve that integration, you will get the constant of integration, and use the boundary conditions to get that constant of integration, so that you will get the generalized form of equation of motion. Again, to get the another equation, again integrate that. But what I suggested, instead of integrating directly, you replace that a either by dv by dt or v into dv by ds. Similarly, when you want to write down the equation of displacement from the equation of velocity, you have replaced that velocity by ds by dt. And then separate the variables and solve the problem. Yeah, I hope you are comfortable with this. We have solved the, means I explain you, and I think we have solved the question also. Am I right? We have solved the sum number 2. Here, in between, we have left that sum at that time. Here, the question was, second question, it was a equal to 30 minus 4.5 x square. Acceleration is given as a function of displacement. So this becomes one equation of motion which is given. Okay. Then it is given that it starts with a 0 initial velocity at x equal to 0. That is at t equal to 0 initially. Here it starts from x, that is z equal to 0, and starts from origin, that is x equal to 0. In the sum, if x is used for the displacement, you can use x. If s is there, use s. Doesn't make any difference. Now you have to find out the velocity when x equal to 3 meter, first one. Second, you have to find out the position, means you have to find out the displacement. Here when velocity is 0, means to calculate this both the terms, here we require velocity as a function of x. अगर ऐसे फॉर्म में मुझे इक्वेशन मिलता है, if I can calculate the type of equation of motion for this particle, then this both the sub questions I can solve. And third point is also there. You have to calculate the position if the velocity is maximum. You have to calculate the displacement when velocity is maximum, and also you have to calculate that maximum velocity. In fact, all the three sub questions you can solve if you know the equation of v as a function of displacement, and that we have written that by replacing this a by v into dv by dx. Don't replace it by dv by dt. If you replace it by dv by dt, then there will be a three variables. Yeah. So we have replaced this a by v into dv by dx, which is equal to 30 minus 4.5 x square. So v into dv equal to 30 minus 4.5 x square dx. Separate the variables, integrating both sides, solve that integration, v square upon 2 equal to 30x minus 4.5 x cube upon 3. Am I right? Plus constant of integration c1 or c. And now use the boundary condition. Then, or let's simplify it, it is v, or let's first use the boundary condition. So when x equal to 0, v equal to 0. If I substitute, c will also be equal to 0. So equation of the velocity becomes v square equal to, I am substituting this c in this equation, I am writing the generalized equation. So v square equal to 60x minus 9x cube upon 3, that is 3x cube, So this is the equation of velocity. Say these are the equation number 1. You can write v equal to under root of that way also you can write. But this is a generalized equation of velocity in terms of x, which is also known as the equation of motion. Okay, now I got the equation in terms of v and x. Now I have to calculate the velocity when x equal to 3 meter. So first one, when x equal to 3 meter, substitute x equal to 3 and tell me how much is the velocity. Unmute yourself and tell me the answer. Actually, we have solved this.
9.95.
9.95.
It was 9.95. Velocity is 9.95 meter per second. First answer. Now second, you have to calculate the displacement. You have to calculate the position when velocity becomes 0. Okay, here, so equation number, point number 2. When v equal to 0, so let's substitute v equal to 0 in equation number 2. So equation number 2 can be written as 0 equal to 60x minus 3x cube. So if I take x common, so it is 60 minus 3x square. That is either x equal to 0 or 60 minus 3x square equal to 0. So this already we know. At x equal to 0, v equal to 0, ये तो दिया ही है. Clear? So we want to calculate the position when velocity again becomes 0. Clear? Means at beginning itself velocity is 0 and after certain instant the velocity again becomes 0. Okay. So let's calculate the x from this one. So it is 3x square equal to 60. So x equal to under root of 20. Here this is the position of the particle. You can simplify this. This is the position of particle when the velocity of the particle again becomes 0. Okay. Now you'll observe that if I simplify the figure, if I draw the simplified figure, so when x equal to 0, velocity is 0. And at x equal to root 20, the velocity again becomes 0. Means meanwhile what is happening? Meanwhile, if I draw the velocity versus displacement graph, it may happen that here initially the velocity is 0 and then it increases and after certain time it decreases and again becomes 0. This is the velocity versus displacement graph. Actually, it is a cubic curve or some quadratic curve will be there. Not cubic, but quadratic curve will be there. Okay. Here, so meanwhile, here at some instant of time or at some particular position, the velocity becomes maximum. So you have to calculate at what position the velocity becomes maximum. First, you have to calculate the position when the velocity is maximum. Have you understood this representation? Okay. Now, solution is very simple. Now, I have to calculate the position when velocity is maximum. Now, I have the velocity as a function of displacement. I have the velocity as a function of displacement. Here, you have solved this. Y as a function of x. Now, for maximization of this y, what we have to do? We have to differentiate this equation and equate it with 0. Here for y max. Here, this concept you have studied in 12th, 11th and 12th. Okay, so for maximization of this function, you have to differentiate it with respect to x and equate it with 0. अगर इसको differentiate किया और equate it with 0 किया तो आपको directly y max नहीं मिलेगा. You will get the value of x at which y is equal to y max. If you substitute this value by equating this equation with 0, जो x का value मिलेगा. If you substitute this x value in this equation, y become y max. At that particular position, the y will be y max. Okay, so when velocity is a function of displacement, listen carefully. When velocity is a function of displacement, I can write down for v max. Here this dv by dx must be equal to 0. Isn't it? Here, or let v is a function of time t, generalize. Here for in this case, if it is asked to calculate the time at which the velocity is maximum, so here also for v max, I have to differentiate this equation dv by dt with respect to t and equate it with 0. But what is this dv by dt? It is nothing but acceleration. It is nothing but acceleration. Similarly, with this v into dv by dx is equal to 0. So here also I can write down, here this dv, on both sides I am multiplying by velocity, so v into dv by dx is equal to 0 and again v into dv by dx is equal to a. So which is equal to 0, a equal to 0. Okay, so this is basic derivative and this is a basic concept. Here you can solve the sum by using the basic concept also. Yeah, but what I am suggesting, Here, remember this condition. Here, whenever it is asked, here whether this equation of velocity is in terms of displacement or whether it is in terms of time. Here, whenever there is a question, here find out the maximum velocity. So remember, whenever there is a maximum velocity, the acceleration has to be equal to 0. At that particular position, at that particular time, the acceleration will be 0. Okay, so directly by equating the equation of acceleration with 0, you will get the डिस्प्लेसमेंट एंड ये डिस्प्लेसमेंट आपका डिस्प्लेसमेंट रहेगा वहां जहां पे वेलोसिटी मैक्सिमम रहेगा. ओके, एक्चुअली नो नीड टू डिफरेंशिएट दिस एंड इक्वेट इट विद 0. अगर किया तो यही आने वाला है. ओके, so just remember this condition whenever there is a question to find out the maximum velocity. So condition for maximum velocity is what? Condition for maximum velocity. क्या कंडीशन है मैक्सिमम वेलोसिटी के लिए? Here, so for maximum velocity, for Vmax, acceleration has to be equal to 0. कंसेप्ट क्या है, क्यों एक्सेलरेशन 0 आता है वो मैंने बोल दिया आपको. Understood? Yes, so directly remember this. For maximum velocity, the acceleration has to be equal to 0. Basic उसका application of derivative. Okay. Now I have to calculate the position when velocity is maximum. Here, third one. I have to calculate the position for Vmax. Now I know that at Vmax, the acceleration equal to 0. Now from equation number 1, I can write here it is 0 equal to 30 minus 4.5 x square. That is x square equal to 30 upon 4.5. You will get this x. Tell me, at what position the velocity will be maximum? So this is the position at which the velocity is maximum. Tell me how much is the answer?
$1.61.
1.61. Listen, 1.16 meter. This is the position where the velocity is maximum. Okay, now I have to calculate the maximum velocity. Now I have the general relation between v and x. Here, this is the general relation between velocity and displacement. And now I know that at this position, the velocity is maximum. Means if I substitute this x value in this equation, v become Vmax. Yes?
It is 2.58.
Okay, it is 2.58. क्यों ऐसा हो रहा है? सिंपल कैलकुलेशन के लिए भी मिस्टेक क्यों हो रहा है? ओके, कैलकुलेशन मिस्टेक नहीं होना चाहिए. In exam, if there is some calculation mistake, listen, if in exam there is a calculation mistake, examiner is not considering that calculation mistake. Okay, आपके पास कैलकुलेटर है तो भी आपका मिस्टेक क्यों होता है? और मैं तो वो कंसिडर करता हूँ एग्जाम में अगर आप कैलकुलेशन मिस्टेक करते हैं तो दैट इज अ सुसाइड. यार अपने हाथ से आप आपका मास कट कर रहे हैं. ओके, यार. So x equal to 2.58 meter. This is the position at which the velocity is maximum. So if I substitute this in equation number 2, substitute in equation 2, here so v becomes Vmax. So calculate this Vmax by substituting x equal to 2.58 in equation number 2. पूछना ही पड़ेगा क्या कि आंसर कितना है करके? कोई अनम्यूट करके नहीं बताएगा? आर यू एम आई ऑडिबल और नॉट?
यस सर.
तो फिर बोलो ना, क्यों नहीं बोलते आप लोग? सब्स्टिट्यूट इन इक्वेशन नंबर 2 x का वैल्यू एंड कैलकुलेट द Vmax. That means v becomes Vmax. सब्स्टिट्यूट करो और बोलो ना मुझे आंसर. Why are you waiting?
Sir, 134.85.
How much? How much is the Vmax? और उसमें x का आंसर तो दिया है 4.47, ये इसका आया होगा। ओके, Vmax का आंसर दिया है 10.16। आपको क्या आ रहा है? What answers are you getting for Vmax?
10.16 सर, 10.16।
10.16। पहला आंसर क्यों रॉन्ग हुआ था? 10.16 meter. This is meter per second. This is the maximum velocity, and this maximum velocity will occur at a position of 2.58 meter from origin. Any difficulty? Understood? Yes, sir. One important thing is that there are some messages on the group. Yes, so my VCT mail, in spite of being active, I didn't receive any invitation. You received the invitation. I sent the invitation not on VCT email ID, on your Gmail ID, because there are some issues in VCT email ID for few students. Okay, and even if you don't receive the invitation on VCT email ID, here you can directly join from that VCT email ID for the meeting. Even if you get the link on the WhatsApp or in another email ID, here through VCT email ID, you can, by using that link, you can join directly. No need to admit if you are joining from the VCT email ID. If you join from some another email ID जिससे invitation नहीं मिलता है, उसके लिए host को admit करना पड़ता है. But if you join through the VCT email ID, you have no need to join to the participant by the admin. Okay, therefore you are on your email, I've sent the link, use that link and join with the VCT email ID. Yes, जिनका active है उनका. Some 3-4 students are there whose email ID is not working, so today I will solve that issue. Any doubt? The next, we'll solve sum number 4. Velocity is given as a function of time. Sum number 4. The velocity of a particle traveling in a straight line is given by v equal to 6t minus 3t square. Velocity is given as a function of time. The t is in seconds. Now at t equal to 0, s equal to 0. This one boundary condition is given. Determine the particle's deceleration. This you have to calculate the acceleration. वो negative आएगा. Negative acceleration is known as a deceleration. Determine the particle's deceleration and position. That is s. In the question s is used, so I will also use s. Determine the particle's deceleration and position when t equal to 3 seconds. At t equal to 3 seconds. So at t equal to 3 seconds, you have to calculate this. Then how far the particle travels during the 3-second time interval? In this 3-second interval, means from 0 to 3 seconds, क्या calculate करने का है? How far the particle travel from 0 to 3 seconds. It means that you have to calculate the distance travel from 0 to 3 seconds. This is the first one, this is second. You have to calculate the distance travel during the 3-second interval. And what is the average speed? In this 3-second interval, you have to calculate the average speed. Here, what formula I told you about the average speed? ये average velocity है, average acceleration है. Average speed के लिए क्या formula बोला था आपको? Average speed. बोलो.
Final minus initial velocity of one time.
Final minus initial क्या?
Displacement.
वो तो एवरेज वेलोसिटी होगा, एवरेज वेलोसिटी होगा, इधर एवरेज स्पीड चाहिए.
Total distance upon total time.
टोटल डिस्टेंस अपॉन टोटल टाइम. यार कभी कभी पीछे लास्ट का रेफर किया करो. total distance upon total time. ओके, यार कुछ पढ़ाई करते जाओ, लास्ट टाइम का कुछ रिवाइज करके आते जाओ, बिकॉज इट इज नॉट पॉसिबल एवरी टाइम टू रिवाइज द एवरीथिंग. या सिर्फ प्रवचन सुनने के लिए नहीं आने का. So average speed equal to total distance upon total time. So you have to calculate the average speed from 0 to 3 seconds. I also told you that here if it is asked to calculate the distance traveled by the particle from T1 to T2, so this distance traveled by the particle from T1 to T2, we have used one formula mod of ST2 minus ST1. ST2 is the displacement at time T2, which you can get by using the displacement equation, and this is displacement at time T1. So distance traveled by the particle from T1 to T2 equal to ST2 minus ST1 in mod, because it is the distance traveled. But when you use this formula, yeah, remember you can use this formula only if from T1 to T2 the particle is moving in the same direction. Here in between this T1 to T2, if the particle reverse the direction of motion, this is T1 and this is T2, and in between the T1 and T2 at time T the particle reverse the direction of motion. Means this time T falls in this interval where the particle reverse the direction of motion. And if this is the case, here then to calculate the distance traveled by particle from T1 to T2, you cannot use this formula. Here in this case, when the distance, when the particle reverses direction of motion, to calculate the distance traveled by the particle from T1 to T2, you have to split this interval into two parts. From T1 to T, एक interval, and from T to T2, another interval. Because the total distance traveled is the summation of this. Yes, so this can be written as here distance traveled by the particle from T1 to T plus distance traveled by the particle from T to T2. Here and from T1 to T, the particle is moving in the same direction, so you can use this formula, which is equal to mod of ST minus ST1 plus distance traveled by the particle from T to T2 can be written as ST minus ST2. Here in this way we can calculate the distance traveled by the particle from T1 to T2. Okay, means whenever there is a question to find out the distance traveled, how far the particle would have been traveled in any interval of time, ये interval कितना भी छोटा रहने दो. Every time here you have to check whether in this interval the particle is moving in the same direction or whether it is reversing the direction of motion. हमेशा ऐसा क्वेश्चन जब भी आता है और ये इंटरवल कितना भी छोटा रहने दो, पहले चेक करने का है कि ये इंटरवल में here whether the particle reverse the direction of motion or not. Okay, here and if the particle reverses direction of motion, whether that time fall in this interval of time or not, ये 0 to 3 के बीच में आता है क्या वो time? Yes, if that time fall in this interval, then you have to split this interval into two parts and you have to use this formula to get the distance traveled. Okay, are you getting it or not? ये समझ में आ रहा है क्या आपको?
Yes sir.
Yes sir.
सर वो रिवर्स लेता है कि नहीं, मतलब वो कैसे पता करने का?
वो कैसे पता करने का? लिसन, ये कैसे पता चलेगा कि रिवर्स करता है या नहीं? यार मैंने बोला कि वो चेक करो कि whether the particle reverse the direction of motion or not. लेकिन कैसे पता चलेगा, कैसे चेक करेंगे कि whether the particle reverse the direction of motion or not? Just remember one thing, whenever the particle reverse the direction of motion, whether it is a horizontal motion along x-axis or whether it is a vertical motion along y-axis, that is the motion under gravity. Whenever the particle reverse the direction of motion, here at this instant, its velocity momentarily becomes zero. Okay, here if I am moving on this direction और मुझे turn करने का है, तो मुझे पहले stop होना पड़ेगा, then I can turn. Yes, similarly in motion and gravity, if I throw this particle in upward direction, when it reverse the direction of motion, ये तो आपको पता होगा. When it reverse the direction of motion, यहाँ का velocity कितना होता है? Velocity at the highest point when it reverse the direction of motion?
Zero.
Here, so whenever the particle reverse the direction of motion, at this instant the velocity momentarily becomes zero. उसके पहले velocity positive होगा, उसके बाद भी negative होगा. Means it changes its direction of motion from positive to negative or from negative to positive, whatever it may be. Here इतना याद रखो कि whenever the particle reverses its direction of motion, here its velocity momentarily becomes zero. So to find out this time, to check whether the particle reverses direction of motion or not, आपको उसका velocity का equation लिखने का है जो दिया ही है. ये क्वेश्चन में अगर नहीं दिया है तो आपको पहले कैलकुलेट करने का है, आपको पहले वेलोसिटी का इक्वेशन लिखने का है. इट मे बी द वेलोसिटी इन फंक्शन, वेलोसिटी एज अ फंक्शन ऑफ टाइम, वेलोसिटी एज अ फंक्शन ऑफ डिस्प्लेसमेंट, कुछ भी रहने दो. ओके, to find whether the particle reverses direction of motion, equate the equation of velocity with 0, you will get the time or position where the particle reverses the direction of motion. Understood? तो कैसे पता चलेगा कि पार्टिकल रिवर्स करता है या नहीं? क्या करना पड़ेगा उसके लिए? वेलोसिटी का इक्वेशन फाइंड आउट करो एंड इक्वेट इट विथ 0. Understood? Understood?
Yes, sir.
Okay. ना अभी सॉल्व करो ये क्वेश्चन, फटाफट सॉल्व करो. Here velocity equation is given, v equal to 60 minus 3t square, equation number 1. मुझे कैलकुलेट करने का है acceleration at t equal to 3 seconds, means I need a equation in terms of a and t. अभी velocity के इक्वेशन से अगर मुझे acceleration का इक्वेशन चाहिए तो क्या करना पड़ेगा? In the last lecture I told you that acceleration से velocity का इक्वेशन अगर फाइंड आउट करने का है तो इंटीग्रेट, velocity से डिस्प्लेसमेंट और इंटीग्रेट. अगर डिस्प्लेसमेंट से velocity कैलकुलेट करने का है तो व्हाट यू हैव टू डू? You have to differentiate. Here v equal to ds by dt. Displacement के इक्वेशन को डिफरेंशिएट करना पड़ेगा. वैसे वेलोसिटी के इक्वेशन को डिफरेंशिएट किया विद रिस्पेक्ट टू t, so you will get the acceleration. Okay. Now I have to calculate the acceleration. So differentiate this equation. So here a equal to dv by dt. So a equal to 6 minus 60. This is the equation of acceleration. So equation number 2. Is that correct?
Yes, sir.
Okay. So at t equal to 3 seconds, so how much is the acceleration? 18 minus 6, it is minus 12 meter per second square. This is the deceleration. We get to acceleration. Okay, this is the acceleration of a particle at t equal to 3 seconds. Understood? Now I have to calculate the displacement. Now velocity का equation पता है मुझे, v equal to 60 minus 3t square, equation number 1. अभी उससे मुझे डिस्प्लेसमेंट का इक्वेशन कैसे मिलेगा? हाउ आई कैन गेट द इक्वेशन ऑफ डिस्प्लेसमेंट? इंटीग्रेट करना पड़ेगा. तो बट इंस्टेड ऑफ इंटीग्रेटिंग डायरेक्टली यू हैव टू इंटीग्रेट इट विद रिस्पेक्ट टू t. But instead of integrating directly, replace this v by ds by dt and separate the variable. So it becomes ds equal to 60 minus 3t square dt. Then integrating both sides. If I integrating both sides, so s equal to 60 square upon 2 minus 3t cube upon 3 plus constant of integration c. That is s equal to 3t square minus t cube plus c. And now use the boundary condition. Now it is given at t equal to 0, s equal to 0. If the boundary conditions are not given, you have to assume the boundary condition. Standard boundary condition आपको assume करने का है. Here, लेकिन ये सब में दिया है. So we know that at t equal to 0, s equal to 0. Substitute in this equation. So c is also equal to 0. Here, substitute this c in this equation and get the general equation of displacement. So it is s equal to 3t square minus t cube. This is the general equation of displacement. So these are the equation number 3. This is vt, at second and st third. Any doubt? Understood? Now I have to calculate the position when t equal to 3 seconds. So at t equal to 3 seconds, here calculate how much is the displacement. Substitute t equal to 3. So it is 3 cube. This is also 3 cube. So s equal to 0. Am I right? Okay, s equal to 0 meter. Now you will observe that is a handle. Here I am just drawing how the particle is moving. You will observe that at t equal to 0 also the displacement is 0. And at t equal to 3 seconds also the displacement is 0. इसका मतलब है initially at t equal to 0 the particle is at origin. And after t equal to 3 seconds also the particle is at origin. Does it mean that during that 3 seconds the particle is stationary and remains at origin? No. Okay, it is moving. Yeah, the velocity equation is given. Yeah, it is not stationary. Yeah, so you have to find out how. अभी देखो, at t equal to 0 the particle is at origin and at t equal to 3 also the particle is at origin. इसका मतलब क्या है? This particle is in motion. Yeah, लेकिन between 0 to 3 somewhere it reverses direction of motion and again come back at origin in that 3 seconds. समझ में आया क्या आपको?
Yes, sir.
Yeah.
Yes, sir.
Now you have to find out how much is the distance traveled by this particle in this 3 seconds. Yeah, let this t1 equal to 0 and t2 equal to 3. Means you have to calculate the distance traveled by the particle from t1 to t2. And we have concluded that in this sum, here in between 0 to 3, the particle reverse the direction of motion. मतलब डायरेक्टली मैं यहाँ पे ये फार्मूला नहीं यूज कर सकता हूँ st2 माइनस st1, क्योंकि ये भी 0 ये भी 0, तो मुझे 0 मिल जाएगा, लेकिन ऐसा नहीं हो रहा है. Here in between the 0 to 3 second, the particle reversing the direction of motion. Here, so in this case, I have to use this concept. मुझे ये इंटरवल दो पार्ट में स्प्लिट करना पड़ेगा. Here from t1 to t, where it reverses direction of motion, and from t to t2. Okay. Now the question is how I can get this time where the particle reverse the direction of motion. वो exactly 1.5 second नहीं होगा. It won't be exactly at the middle. Okay. Here, so tell me how I can get that.
V is equal to 0.
V is equal to 0.
V equal to 0. Okay. So to get time at which particle reverse the direction of motion, at which the particle reverse the direction of motion, here equate V with 0. Now we have the equation of velocity. Okay, we have the equation of velocity. So velocity equation is V equal to 60 minus 3t square. Let equate it with 0. So it is 60 minus 3t square. If I take t common, then it is 6 minus 3t. Here means at t equal to 0, the V equal to 0, but that is given. ये पहला ही position आ गया. At t equal to 0, V equal to 0. Means it must start from its motion. Here and then what is another t? Here that is 6 minus 3t equal to 0. That is t equal to 2. Here, so this is our valid answer. So at t equal to 2 seconds, the particle reverse the direction of motion. At t equal to 2 seconds, the particle reverse the direction of motion. Understood? Have you understood this?
Yes, sir.
Okay.
Yes, sir.
Now tell me how we can calculate the distance traveled by the particle from 0 to 3 seconds. Distance traveled from 0 to 3 seconds. So it is d. I am denoting it by d from 0 to 3 seconds. क्या करना पड़ेगा? अभी इसमें 0 to 2 सेकंड के बीच में at t equal to 2 सेकंड, 0 to 3 सेकंड के बीच में at t equal to 2 सेकंड, the particle reversing the direction of motion. मतलब मुझे ये टोटल इंटरवल दो पार्ट में स्प्लिट करना पड़ेगा. So first I will calculate the distance traveled by the particle from 0 to 2 seconds, plus separately I will calculate the distance traveled by the particle from 2 to 3 seconds. How I can get the distance traveled by the particle from 0 to 2 seconds? It is mod of displacement at 2 seconds minus displacement at 0 seconds. Plus how I can get the distance traveled by the particle from 2 to 3 seconds? It is displacement at 2 seconds minus displacement at 3 seconds. Yes, so it is displacement at 2 seconds minus displacement at 3 seconds. या displacement का difference ले लो. Okay, and since we are taking it in the separate mod, doesn't make any difference whether you are writing S0 minus S2 or S2 minus S0. Yes, now we know that at t equal to 0, S equal to 0, मतलब S0 पता है हम लोगों को. We have also calculated at t equal to 3 seconds, the displacement is 0. S3 भी पता है. Here, S0 हम लोगों को पता है 0 है, S3 हम लोगों को पता है 0 है. Now let's calculate the S2. Displacement at t equal to 2 seconds, which is the maximum displacement. Here, how I can get the displacement at t equal to 2 seconds? I have the equation of displacement. Substitute t equal to 2 in this equation. It is 4, 3 is 12, 12 minus 8. It is 4 meters. Is that correct calculation? If I substitute t equal to 2, 2 square 4, 4 3 is 12, and 2 cube 8, 12 minus 8, 4. Correct है क्या? Now substitute in this equation. So this is 4 meter plus 4 meter, which is equal to 8 meter. This is the total distance traveled by the particle in 3 seconds. Total distance is 8 meters. Yes. So how much is the total distance traveled by the particle? It is 8 meter. क्या बाकी रहा अभी? अभी बाकी रहा average speed. Okay, how we can calculate the average speed? Average speed you have to calculate from 0 to 3 seconds. So average speed is equal to the total distance traveled in that 3 seconds upon total time. Now, how much is the total distance traveled by the particle in that 3 seconds? How much is the total distance traveled by the particle in that 3 seconds?
8 meters.
8 meter. Okay, that we have calculated. So total distance travel is 8 meter and total time is 3 seconds. So we'll get the average speed in meter per second. Understood? Any difficulty? Seventh sum is also similar. You have to calculate the distance travel or change in displacement when the velocity changes from 1 meter per second to 3 meters per second. You think and try to solve. 6 is also similar. Now we'll solve sum number 8. That will be the last question on this topic, variable acceleration motion. This lesson is actually very lengthy. We'll solve sum number 8. ये देखो कंसेप्ट यही रहेगा, आपको डिफिकल्टी सी पाएगा इंटीग्रेशन और डेरिवेटिव में. ओके, so you should know the basic formulas of integration and derivative. That's all. बाकी कुछ नहीं है, बाकी यही कंसेप्ट है. कभी आपको डिफरेंशिएट करना पड़ेगा, कभी इंटीग्रेट करना पड़ेगा. Here all concepts I explain to you. Okay, sum number 8. A particle start from rest from origin. First sentence दिया है, particle start from rest from origin. इसका मतलब क्या है? Particle start from rest means at t equal to 0, v equal to 0. And from origin means at t equal to 0, x is also equal to 0 or s is also equal to 0. Okay, boundary conditions are given. And its acceleration is given by a equal to k upon x plus 4 whole square. K is one of the constants. Okay, a equal to k upon x plus 4 whole square. Equation of acceleration is given. Now knowing that v equal to 4 meter per second when x equal to 8 meter, और एक बाउंड्री कंडीशन दिया है. When अभी इसमें डिस्प्लेसमेंट x लिखा है तो मैं इसमें इधर भी x लिखता हूँ. Now when x equal to 8 meter, when the particle is at the distance of 8 meter from origin, here the velocity is 4 meter per second. ये बाउंड्री कंडीशन दिया है. Okay, now you will observe that here x और v का दो बाउंड्री कंडीशन दिया है. When x equal to 0, v equal to 0, and again when x equal to 8 meter, the velocity is 4 meter per second. दो बाउंड्री कंडीशंस दिया है. Here why the same two boundary conditions are given? The reason is that in this equation already one constant is there. उसको इंटीग्रेट करने के बाद में और एक कांस्टेंट आएगा. There will be the two constants, and to get that two constant, here we require the two equations, and to get that two equations we require the two boundary conditions. That's why two boundary conditions are given over here. It is given that determine the time interval and displacement of the particle. Sorry. Knowing that v equal to 4 meter per second when x equal to 8 meter, find the value of k. You have to find out the value of k. Second, you have to calculate the position of the particle. You have to calculate the x. Position means you have to calculate the x. Then v equal to कहाँ का position calculate करने का है? When velocity becomes 4.5 meter per second. Yeah, these two values you have to calculate in this question. Okay. Now we have to calculate the x when v equal to 4.5 meter per second. To calculate this, I required velocity as a function of x. ये टाइप का इक्वेशन लगेगा मुझे, isn't it? Here an acceleration is given as a function of displacement. A is given as k upon x plus 4 whole square. Now from this one to get the equation, these are the equation number 1. From this one to get the equation of velocity, here you have to integrate this, but instead of integrating, here let's replace this a by v into dv by dx. You cannot replace it by dv by dt. कि t के टर्म में इक्वेशन आएगा, we don't want. Okay, neither we want in terms of t, and second difficulty is that there will be the 3 unknowns. Yeah, that we don't want. Okay, so k upon x plus 4 whole square. Now separate the variables. If I separate the variable, it is d into dv, v into dv equal to k upon x plus 4 whole square into dx. X का term एक side में लिया, v का term एक side में लिया. Now integrating. Now integration of v into dv, it is v square upon 2 equal to, here k is constant, I am taking it outside. Here, so it is integration of 1 upon x plus 4 whole square. Tell me.
Minus 1 by x plus 4.
Tell me, just 1 minute.
Minus 1
ये
by
इंटीग्रेशन कर चाहिए मुझे x plus 4 whole square with respect to x. बोलो.
minus 1 by x plus 4.
Into coefficient of x which is 1. Okay. Here plus c. Here ये देख लो इंटीग्रेशन, इसका इंटीग्रेशन ये कैसे आया. Not that difficult. Simple integration है. This year you have to solve the double integration. In next semester triple integration. So the basic integration आपको आना ही चाहिए. So v square upon 2 equal to k into in bracket minus 1 upon x plus 4 plus c. Any difficulty in this one? Or if I simplify this, the equation becomes v square upon 2 equal to minus k upon x plus 4 plus c. अभी देखो इसमें दो कांस्टेंट आ गए k और c. And to get that two constant to write down the general equation of v in terms of s, here I require the two equations. And वो दो equations के लिए ये दो boundary conditions दिए हैं. Understood? Here I am considering these are the equation number 2. Now let's use the one boundary condition. We know that when v equal to 0, x equal to 0. Let's substitute. It is 0 equal to minus k upon 4 plus c. Okay, that is c equal to k upon 4. Okay, how to get the another equation? Use another boundary condition in the same equation. Use another boundary condition in the same equation. The second boundary condition is given that when x equal to 8 meter, v equal to 4 meter per second. Let's substitute in this equation number 2. So equation number 2 can be written as, it is 4 square upon 2, that is 8, equal to minus k upon x plus 4, that is 12 plus c. तो यहाँ से एक इक्वेशन मिल गया आपको. Solve these two equations. Substitute c equal to k by 4. So 8 equal to minus k upon 12 plus k upon 4. आपको यहाँ से k मिल जाएगा. Simplify that.
Sir, k equal to 48.
K equal to 48. K equal to 48. Yes, correct answer है. I hope सबको पता है ये कैसे सॉल्व कर देगा. 8th स्टैंडर्ड में, 7th स्टैंडर्ड में एलसीएम लेके जो आपको मेथड पता है उससे सॉल्व करो. या तो अगर कुछ नहीं आता है तो सॉल्व फंक्शन यूज करो. मैंने बोला है आपको कि एक इक्वेशन और एक अननोन है ना, तो यूज सॉल्व फंक्शन, आंसर आ जाएगा. K equal to 48 meter. Substituting this K equal to 48 in this equation, you will get C. So 48 upon 4, it is 12. C equal to 12. So equation of velocity becomes v square upon 2 equal to minus k upon x plus 4 plus c, that is 12, or in this K is 48. This is the equation of velocity as a function of displacement. Now you have to find out the position when v equal to 4.5, substitute v equal to 4.5 and get the answer of x. Okay, you have to calculate x when v equal to 4.5. Substitute in this equation and tell me the value of x. How much? Why so much time is required? Come on, fast. Tell me what is the value of x?
$91.61.
21.61. Any doubt? Here I am finding this topic over here only. Variable acceleration motion. Last lecture एक लिया और ये एक lecture हो गया. Here so 2 hours are enough for this. Here for remaining some concept I explained, all the concepts I explained. Okay, just do the practice and very important topic. Most of the time there is a question on this topic. Okay, and easy है. कभी आपको integrate करने का है, कभी differentiate करने का है. That's all. Then second topic is the uniform acceleration motion from this here in which you have to use this kinematic equations. Directly equation use करने का है. Write down the given data and directly use the equations here. And this part is for the self study. Okay, so do that. Yeah. Then next one is the third part of rectilinear motion is the motion under gravity. Yesterday on your Google Classroom, I uploaded the syllabus also. देखा क्या आपने? Uploaded the syllabus. Here then I have created the space for the assignment also. Today is the last date. Till 12 o'clock you can submit the assignment. Any doubt? So you go through that syllabus of engineering mechanics. In that syllabus, it is clearly given that the uniform acceleration motion and the motion under gravity are for self-study. Because both the topics you have studied in your junior college level. Motion under gravity भी आपने study किया है. Okay, here go for this motion under gravity. Here and uniform acceleration motion. Here it is for the self-study. Actually, everything is given in this question bank. Motion under gravity का जो theory दिया है ना, read that theory first carefully. एकदम carefully theory study करने का है. Here page number 6, 5 and 6 पे theory दिया है. And number of points are given. Points to be remembered while solving the problems based on the motion under gravity. Here you have to read all that points carefully. You have to apply that points while solving the sum on motion under gravity. Okay. So this motion under gravity and this is for self-study. Now we'll move ahead and the fourth topic which we have to solve is the motion curve. Okay, important topic, motion curve. All of you have written your name and roll number in the chat box.
Yes, sir.
Okay, now I am ending this meeting here itself. Otherwise that video becomes too lengthy. 2 hours का video हो जाएगा. Yes, I am ending this meeting here itself. Here and after take the break of 5 minutes. After the 5 minutes, here again you have to rejoin with the same link. Okay.